Hello, welcome to Chapter 2. We're going to talk about integers in Chapter 2. And to get a handle on these, we need to get some context. What do we need an integer for? What was wrong with all the numbers we've been using? So here's a description of something. A worker in a silver mine in Nevada works 1,445 feet underground. How do we represent that situation with numbers? Well, it looks like we already have, right? We've got 1,445. But if I just say 1,445, then for 1,445 feet, I have no way of distinguishing between the guy down here. Let me see if I can get rid of this thing. The guy who is working down here in this little mine under the ground. There he is. Little guy there. We'll give him a pickaxe. And he's working in the mine. He's mining. And he's 1,445 feet under the ground. And this other guy up here, see if I can get my pen to work, and he is flying along in his airplane, and he is right up there. He's waving at the guy down below. And let's just say that he is exactly 1,445 feet in the air. Do you see how that is confusing? Because if I said, I want the guy who's 1,445 feet away from, let's say, me standing right here on the ground. Let's see, what do I look like? Well, let's see, no hair. There we go. So which is the guy who's 1,445? See, notice that it's awkward and confusing having two different places in relationship to me that are in two different directions. We need a number, we need a way to differentiate between those locations. One is up in the air, one is below the ground. And so that's where integers come in. Integers say, well, let's make a giant number line here. Let's see, we'll do it with, oh, that is just going to give me trouble today. No. Let's make a giant number line here. And we'll put 0 there. And we'll put 1,445 up there. And lots of little marks for all the numbers between 0 and 1,445. And then if we do that logically, we could just extend that number line down the same amount, 1,445, and we could say that when we go this direction, we're going in the positive direction, and then when we go this direction, we're going in the negative direction. So we'll call this negative 1,445 because it is the opposite of what we might call the positive 1,445, which would be up in the air. So positive would be up, negative would be down. Now, there's no rule that says going up is positive and down is negative, but it just sounds more natural to us. So, in general, when you say this, people are going to say, well, up is positive, down is negative. And when we take this number line and we lay it down flat on the table in front of us, we're going to say that to the left is negative. Those are all the negative numbers. And to the right is positive. And those are all the positive numbers. And this has some advantage to us because then we have all the smaller numbers are on the left and the bigger numbers are on the right. We always read left to right, so we read from the smaller to the bigger, and we can put things in order easily, which we'll do in just a little bit. Okay, so that's integers, and in today's lesson, the first thing that you're going to say is, wait a second, is that it? That's all? Because we're not actually doing anything with integers. Well, not much. We are just basically saying they exist. Integers exist. Integers are numbers that can be positive or negative. And notice this, that we're still talking about whole numbers. We haven't even got to fractions. There's no decimals. It's just positive and negative numbers that are whole numbers. Okay. Now, this question number 2 says use a number line to order these numbers from least to greatest. And then that's one of the great values of the number line, is we can just kind of see where everything is in relationship to everything else. So I'm going to draw a number line. I would like you to learn to draw a number line, but oftentimes the number line will be given to you. And the way we draw a number line is we just draw a line straight across, and put arrows on the end to show that it goes on forever. And then typically, we'll look at the numbers we're going to graph, and we're going to say, okay, what size number line do we need? What units do we need? And here we've got some positive numbers, 4 and 3, some negative numbers all the way down to -7. So we need to go at least to -7 and at least to +4. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. All right, that's enough on the positive side. And then I'm going to count the exact same way going down. 1, 2, that's -2. 3, 4, that's -4. 5, 6, -6. 7, 8, -8. Okay, now it is not true that number lines have to be even, like the same numbers on both sides. And that, like when you're drawing a number line and you're looking like you're going to use it for something, we never draw the entire number line. Let's just say that up front. We never draw the entire number line because the entire number line is infinite. So we always have to draw a piece of it. So we have to decide which piece of the number line do I need to use. What's the biggest number I'm going to graph? What's the smallest number I'm going to graph? But the rule is that in general we like to have 0 on there if we can fit it. But we want the little marks, we call these hash marks, to be equally spaced. And each hash mark needs to stand for the same thing, the same length unit. So in my case here, each hash mark stands for 1. So this first hash mark is 1 over, from 0 is 1. And then another 1 over from there is 2. And another 1 over from there is 3, and so on. And the same units apply going down, going in the negative direction. That's -1, -2, -3. Okay, so that's the important key. You have to have these little hash marks that show you the exact same distance. Now, here's how we graph, and I'm going to use a different color because I want to really distinguish the difference between a number line, which is all I've done here. I drew a number line, and that's like the canvas. So I'm going to graph on the number line. I haven't graphed anything yet. And then graphing the numbers on the number line, I find the hash mark that corresponds to the number I want. I'm going to start with -1. So -1 is right here between 0 and 2, and I'm going to put a dot on the line there. That's -1. Now notice I didn't write the number -1 anywhere. I don't actually have to because I did my number line with enough neatness that everybody can see that's -1. It's right between 0 and -2. I'll find -4, or +4, sorry, +4 on the positive side. And then -7 is there between -6 and -8. And then 3 is between 2 and 4. And -5 is between -4 and -6. Now notice that my dots are not equally spaced. That's because the dots represent these numbers that I'm trying to graph. So there's nothing that says those numbers had to be equally spaced. But they all fit within the number line. Okay, now I'm going to put these in order, and they're already in order. I'm just going to write down the name of each number. So the first one on the far left is -7. Then comes -5. Then comes -1. Then 3. And then 4. And there are my numbers, the same numbers that I had listed before, but this time they're in order from smallest to largest. Notice that the very, very small negative numbers actually look like big numbers. -7 looks like we're used to thinking of 7 being bigger than 5, certainly bigger than 1, but -7 is smaller than -1. So in direction, -7 is to the left of -1, so it's smaller. We can think of it like if you're thinking of temperature. If this is a thermometer, -7 degrees is colder, has less heat than -1 degree. Okay. Let's show one more thing, and I say one, but I'm going to show you like 8 things. But we'll do this fairly quickly. The last thing we want to talk about today is absolute value. And what's the point of absolute value? Well, let's start by answering the question, what is the absolute value of -2? You probably already know the answer to that is 2. But if you knew that, then you're probably a little bit confused about the question, what's the absolute value of +2? Because it seems like we did something in the first problem, absolute value of -2 is 2. We should do something similar in the second problem. So a lot of students say the absolute value of +2 is -2. But that's not the way it is. In fact, the absolute value of 2 is also 2. And what does that mean? Well, let's go back to our number line. This time I'll use the number line that has a 1 and a 2 and a 3. We'll go over it to 4, but we won't worry about it. Now, we have +2 on the number line, and we have -2 on the number line. But the absolute value of -2 is 2, and the absolute value of +2 is 2. What does that mean? Well, absolute value means the distance from that point right there, 0. How far is it from that point to our number? And the distance from 0 to 2 is 2 spaces. And the distance from 0 to -2 is 2 spaces. So the absolute value of 2 and the absolute value of -2 are both 2, because absolute value deals with distance. Let me explain, and And let's think about this. Why would we need this in a math class? Well, let's just say that I'm standing here teaching math, and you walk in the door of my classroom. Okay. Now, how far is it from me to the door? Let's say that it's 5 feet. Now, if you walk in the door, you're standing right there in the doorway. You look much better than I do. How far is it from you to me? There, teaching math at the front of the class. How far? Well, what's that distance? Well, if we were thinking of the number line, we would be tempted to say -5 feet. But is that really what you said? I bet you didn't say that. And nobody says that. Nobody says it's -5 feet. Because the question I was asking was, how far away are we? Like, how far is it from you to me, and how far is it from me to you? And the answer is the same any way you measure it. But if we took a number line and measured with a number line, going one direction would be positive, and going the other direction would be negative. So we need some sort of mechanism, some sort of tool that will help us to turn measurement on the number line, or with mathematical operations, which we'll do later, into a distance which is always positive. And that's what absolute value does for us. It takes negative numbers and makes them positive, takes positive numbers and keeps them positive. Okay, let me give you 2 real quick trick questions. How about this one right here? We've got number 5, negative absolute value of -2. Well, the absolute value sign, I'm having trouble with my pen getting that to draw exactly what I want, but that absolute value sign is impacting everything inside the absolute value. Okay, so that means that -2 inside the absolute value sign is going to become positive. So that absolute value turns the -2 into a +2. But the absolute value sign was not at all around the negative sign that was outside, so that's still there. And so that negative sign is still there, so it's negative. Absolute value of -2 is negative. Well, the absolute value of -2 is 2, so just -2, so it's -2. Okay, does that make sense? It's confusing. Let's see if we can figure out number 6. Kind of the same question, only this time we have the absolute value +2. Remember, the absolute value just makes whatever it is positive. It's positive, so it's +2. But then this negative sign outside the absolute value sign is still there. And the absolute value, or the negative of that 2 is just -2. Okay, let me show you these last 2, and I think we've already done this. So let's do a graph here. We're going to draw a number line, and we have 0, 1, 2, -1, -2. So let's graph that let's graph that 2. So we're going to graph 2, and we're just going to start at 0, and we count 1, 2, and we put a dot there. Okay, that's graphing. Now let's graph -2. We start at the 0, and we go backwards, go in the negative direction, 1, 2, and we put a dot there. Okay, now what about this next one? -2. Well, The negative 2 says, let's go backwards, negative 2. But the negative 2 says, do the opposite of that. So the negative in front, outside the parentheses, says do the opposite. So negative 2 means go in the opposite of what you wanted to do. Negative 2. Does that make sense? So negative 2 is 2. Just like, and this one's not that hard, negative parenthesis 2 says do the opposite of 2, right? Negative 2 just means instead of going to 2, do the opposite, go to negative 2. So in the same way, if I say negative 2, I mean do the opposite of negative 2. Don't go to negative 2, go to positive 2. Okay. Whew. This is brain-bending stuff. Do the best you can with it, but please, 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 do each problem and check your answer. This is really great. This is where the textbook really shines, because here you're going to know how to do this right if you don't know already. If you didn't know already, you would know immediately as soon as you check your answer, because you're going to answer, you're going to say, oh, I think it's this, and then it's going to say, nope, it's that, and you're like, oh, okay, and now I know. I'm supposed to do that instead of this. So check your answers, and you should be just fine here. It's okay if you get a couple wrong, but you want to just give yourself lots of practice dealing with integers. Thanks for watching.